You push on a door near the handle, not near the hinges, because it feels easier. A small person can lift a heavy rock with a long crowbar. A bike climbs a hill better in a low gear. These are all the same idea. Gears and levers do not create force, they change how force is applied. The rule that keeps everything honest is energy conservation. In an ideal machine, the work you put in equals the work you get out. Work is force times distance. So if a machine gives you more force, it must give you less distance or less speed. Force multiplication is always a trade. Here is the core relationship. Input force times input distance is approximately equal to output force times output distance. If the output force is bigger, the output distance must be smaller. That is the entire secret. Start with levers because they are the simplest. A lever is a rigid bar that rotates around a pivot called a fulcrum. What matters is not just how hard you push, but how far from the pivot you push. The turning effect is called torque. Torque equals force times the perpendicular distance from the pivot. For a lever that is lifting slowly or holding still, the torques balance. Input force times input distance equals output force times output distance. Rearranging this shows the mechanical advantage. The output force divided by the input force equals the input distance divided by the output distance. Push farther from the pivot and you need less force, but your hands move about 2.7 times farther than the load. The different classes of levers do not change the physics, they only describe where the pivot is placed. In a Class 2 lever, like a wheelbarrow, the load is between the pivot and your hands, so the input distance is always longer and the lever always multiplies force. In a Class 3 lever, like your forearm, your muscle attaches close to the pivot, so you lose force but gain speed and range of motion. Biology chooses speed and control on purpose. Now shift to gears. A gear is just a lever wrapped into a circle. Instead of a straight distance from a pivot, you use a radius from the center. The rotational version of force is torque, and the rotational version of speed is angular speed. Power is torque times angular speed. In an ideal gear system, power in equals power out. If torque goes up, speed must go down. At the point where two gears touch, the teeth push on each other with the same tangential force. The torque on a gear equals that tangential force times the gear's radius. So if one gear has a larger radius, the same force produces more torque on it. That is force multiplication in gears. Because gear teeth are the same size, a larger gear has more teeth. Radius is proportional to tooth count. This leads to the gear ratio. Gear ratio equals the number of teeth on the output gear divided by the number of teeth on the input gear. The output torque equals the input torque times the gear ratio. The output speed equals the input speed divided by the gear ratio. For example, a 20-tooth gear driving a 40-tooth gear has a gear ratio of 2. The output gear turns at half the speed, but with twice the torque. If the input torque is 15 Newton meters, the output torque is 30. Nothing was created. Speed was traded for torque. You can also see the distance trade directly. Points on the rims of the gears move through arc lengths. Those arc lengths must match at the contact point. A larger radius means the gear turns through a smaller angle. Less rotation, more torque. Same trade as the lever. In real machines, friction and deformation steal some energy. That means you must push a little harder than the ideal equations predict. But friction never breaks the rule. You can never get more energy out than you put in. Here is the unifying picture. Levers use torque equal to force times distance. Gears use torque equal to force times radius. A gear's radius is just a lever arm. Both obey the same conservation law. More force or torque always comes with less motion or speed. So remember this, machines do not make you stronger, they rearrange distance and speed so your force is applied more usefully. Long levers and big gears give high force and slow motion. Short levers and small gears give low force and fast motion. Every gear and every lever is the same trade, just drawn in a different shape.